The principle of manometry is one of the most important methods in hydrostatics, and it can be used to solve many hydrostatics problems a lot faster than using the hydrostatic algebraic equation. While we have already discussed this method in a previous video, it never hurts to see more examples of this important topic if you are preparing for your fluid mechanics midterm and final exams, or the FE exam. In today's video, we are going to walk through a step-by-step process to solve unknown hydrostatic pressure using the principle of manometry. Let's have a quick revisit of the principle of manometry first. As the equation shows, if we are given the pressure on one side of the manometer and we are asked to calculate the pressure on the other side, we will need to start an imaginary journey from the known side towards the unknown side. The journey will need to be broken down into parts at the interface of two different fluids. At the interface, if we have traveled downward in elevation, we will add some pressure, calculated using specific weight, gamma, multiplied by the elevation change, delta z. If we have traveled upward in elevation, we will then subtract some pressure equivalent to the products of the specific weight of the fluid we traveled in and the elevation change. We will do these additions and subtractions until we eventually arrive at the location where the unknown pressure is demanded. Let's take a look at this specific example. As shown by this image, we have a manometer that connects to the air pressure of 150 kPa on the right side end. There are three different fluids in this manometer with three different colors: green, blue, and red. The specific gravity of these fluids are given, and the elevation variations can be measured. What would be the pressure reading of the pressure gauge on the left side end? So first of all, let's be aware of the known and unknown pressures. The gas pressure 150 kPa on the right side end of the manometer is given, so it is a known pressure, that is P sub A in the equation. Whereas the gauge reading on the left side end of the manometer is to be determined. Obviously, this is an unknown pressure. As discussed earlier, we will start an imaginary journey through the different fluids by going from the known towards the unknown, segmented by the interfaces between fluids. As we start from the interface of air and the green fluid, the pressure at this interface is approximately the same as 150 kPa because air, with a specific gravity of approximately 0.00121, has a significantly smaller specific weight than the liquid. This travel happens in the green fluid, so the specific weight of the green fluid should be used for pressure calculation. We go down, go up, go down, and then go up again. It doesn't matter how we change the elevation in between, because we will only compare the elevations of the starting interface and the ending interface. Our first part of the journey ends at the interface between the green fluid and the blue fluid. Compared to the starting point of this part of the journey, we went down in elevation by 10 centimeters. So as we said, we will add some pressure here, and therefore plus is used here. As we continue our journey, we enter the blue fluid, going towards the interface between the blue fluid and the red fluids. The specific weight of the blue fluid should be used here. This time, the ending interface has a higher elevation than the starting interface, meaning that we have increased in elevation by 15 centimeters. So some pressure shall be deducted, and therefore minus is used here. And next, we are in the red fluid. going downwards until the interface between the red and the blue fluid. Clearly, we go down in elevation and we will increase in pressure. To calculate this pressure increase, we will use the specific weight of the red fluid and the elevation change of 14 centimeters. The operation plus should be executed. And finally, we are back in the blue fluid, going down and then going up all the way to connect to the pressure gauge. The elevation has increased in this part of the journey, resulting in subtracting corresponding pressure, which is calculated using the specific weight of the blue fluid and the elevation change of 14 centimeters. We have finally finished our long journey from the beginning of the manometer till the end of it that is connected to a pressure gauge. The corresponding equation is shown here in this slide. This is naturally developed as we imagine our journey through the fluid. Now let's recall that the specific weight of each fluid can be calculated using their specific gravity and the specific weight of water at 4 degrees Celsius. And the last step of this solution process is the easiest. We substitute the given values with appropriate units into the developed equation, and with the help of a calculator or a superpower brain, we can soon find the answer. And the final answer is approximately 166.2 kilopascal. And this is going to be the reading of the pressure gauge. If you found this video helpful, please like the video, subscribe to the channel, and leave a comment with the next topic you'd like me to cover. Your engagement is my biggest motivation. Thanks again, and I'll see you in the next one.